So what is L'Hopital's rule? Well, what I've seen in several of my classes is students learn L'Hopital's rule, or they use some of the cheating things like photomath or Wolfram Alpha, and the solution that they provided on the test was using L'Hopital's rule back in the limits section. It's really funny to me because L'Hopital's rule is not taught until the end of the semester. So people who used L'Hopital's rule early on actually did not receive credit on the test because they used rules that we had not established yet. So what does L'Hopital's rule allow us to do? Well, let's look at this. It says to find a limit illustrated in the previous example, you can use a theorem called L'Hopital's rule. It says this theorem states that under certain conditions, the limit of the quotient of f of x over g of x is determined by the limit or the quotient of the derivatives. So in other words, what you do, and this is not the quotient rule whatsoever, is you find the derivative of the numerator, the derivative of the denominator, and then you find the limit of that derivatives, the derivative of the top over the derivative of the bottom, okay? Not at all like the quotient rule. You're not doing low d high minus high d low, okay? It's nothing like that whatsoever, but here it goes. It says let f and g be functions that are differentiable on an open interval containing c, except possibly at c itself. So if they're differentiable, remember they're also continuous. It says assume that g prime of x is not equal to 0. That's what that's supposed to say. Not equal to 0 for all x in a, b, except for possibly at c itself. So what the issue is here is we're dividing by g of x, right? And which is going to turn into g prime of x. You just got to make sure you can't divide by 0. That's all that's saying. It says that the limit of f of x over g of x as x approaches c produces the indeterminate form 0 over 0. Then the limit as x approaches c of f of x over g of x equals the limit as x approaches c of the derivative of f of x over the derivative of g of x. So what it says is take the derivative of the top, take the derivative of the bottom, and reevaluate the limit. It's a really, really cool trick. But this only works if you're of certain forms. What forms does L'Hopital work with? It works if you have 0 over 0 or if you have plus or minus infinity over plus or minus infinity. It doesn't matter which sign you have, but if you have any of those two forms right there, you can use L'Hopital's rule. It says this result also applies to f of x and g of x as x approaches c when it produces the indeterminate form. Same thing, plus or minus infinity over plus or minus infinity. So you must show that the first limit is 0 over 0 or infinity over infinity plus or minus, right? That's the first thing you have to do is you have to meet the conditions. It has to be a continuous function, and when you evaluate the limit of the quotient, you have to get one of those two forms right there. It says, note, people occasionally use L'Hopital's rule incorrectly by applying the quotient rule to f of x over g of x. So remember, we are just finding the derivative of f of x over the derivative of g of x. We are not using the quotient rule. And that can be really hard to distinguish L'Hopital's rule versus the quotient rule. L'Hopital's rule only works for limits. The quotient rule works for derivatives, okay? So L'Hopital's rule only works for limits. So let's go back to that previous example. We know the answer here from the previous page has to be 2, but how could we get 2? Well, notice if we plug this in, we get e to the 2 times 0 minus 1 all over 0, and e to the 2 times 0 is e to the 0, which is 1. 1 minus 1 is 0. So we get 0 over 0, which is our indeterminate form. That is what we need to show, okay? So now apply, and I'm just going to put L'(h) rule for L'Hopital's rule. I have to show that I've met the conditions, that it is an indeterminate form. Now I can apply L'Hopital's rule. So I'm going to do some side math over here. I'm going to say the derivative with respect to x of e to the 2x minus 1. Well, the derivative of e to the 2x is e to the 2x times the derivative of the numerator, which would be a 2. The derivative of negative 1 is 0. So that's the derivative of the top. Now I'm going to do the derivative of the bottom. The derivative with respect to x of x, is equal to 1. So by L'Hopital's rule, this is equal to the limit as x approaches 0 of, instead of using the original e to the 2x minus 1, we're actually going to use its derivative. The derivative of it is 2 e to the 2x over, and now instead of using x, we're going to use its derivative, which is just 1. So this is where we would put the 1, okay? So that's what we do, is we just substitute in the derivative of the top, the derivative of the bottom, and that's what we end up getting. So this would be equal to, the limit as x approaches 0, didn't really need to show this step, but I'm going to, of 2e to the 2x, which is simply 2e to the 2 times 0. We can actually plug the number in. E to the 2 times 0 is e to the 0, which is 1, so this would be 2. And that's how we could get our answer without using technology, without having to use the table feature on our calculator. Using L'Hopital's rule, we can get that answer. Let's give it a try again. Let's look at example 2 here. It says the limit as x approaches infinity of the natural log of x over x. Well, if we tried to evaluate that directly, notice natural log of x as x approaches infinity also approaches infinity. And then x on bottom would approach infinity. So it's infinity over infinity, which is our indeterminate form. Since it's our indeterminate form, we could say by L'Hopital's rule, this has to equal the limit as x approaches infinity of the derivative of natural log of x, notice that is 1 over x, all over the derivative of x, which would just be a 1. Simplifying this would be the limit as x approaches infinity of 1 over x, and notice as x approaches infinity, 1 over x approaches 0. So the answer would be 0.